Welcome to our review of lateral surface area, regular surface area, and volume. Remember that the volume is the space inside a three-dimensional object. How much product can I fit inside? Surface area is the total area of a 3D object, the outside pieces, when I add them all together. So I like to think of a soup can. It's going to be the metal piece on top that we cut off with the can opener, the metal piece on the bottom that holds all the information or contents inside, and the metal that goes around the outside edge. That is the surface area. The lateral surface area, again, is a surface area, but it's just of the lateral. It's just of the side. You have lateral muscles. They are on the side of your body. If you throw a lateral pass, you are throwing a pass from the side. So just remember that lateral means a side. In this case, it's the surface area of the sides of the object. So when I think about, again, my soup can example, I'm thinking about the place where the label would go around the outside. For Hormel chili, it's where the label goes around the outside of that can. Find the perimeter of the base and multiply it by the height of any three-dimensional figure. That's how we're going to solve it. So what I want to do is I'm going to bring you into an example here, and we're just going to look at this example. We're going to analyze it a little bit, and we're going to come up with the different formulas that I would use to find the surface area, lateral surface area, and volume of this cylinder. A prism is going to be done the exact same way. You're just not going to use some of the exact formulas because you're not going to need pi when you have a lateral surface area. All right, or regular surface area if it's not a cylinder. All right, so first of all, let us talk about lateral surface area. Lateral surface area, we're just going to say as LA, lateral area. And when we talk about this, it's just where the soup can label will go, which means I don't want to include this top part and I don't want to include the bottom. All I want is this part. Now imagine taking a toilet paper roll after the toilet paper has been used, and you're going to cut the entire side and open it up. It's going to turn into a rectangle, maybe even a square. I should check that out. I don't know how proportional it is. You're going to get this rectangle. We know that the height of that rectangle is going to be the same thing as the height of the cylinder. So in this example, it's going to be 40 inches. The question then becomes, how long is this piece? And that's the challenge, because I see that this is straight and down here it's curved and it doesn't make any sense in my brain. Well, imagine taking a sheet of paper or that toilet paper roll and letting it go. It's going to curl back up. And this bottom piece right here is going to end up being the same as the distance around the bottom. Remember, distance around is the same thing as perimeter. And the special vocabulary word for cylinders means it's the circumference. So all I want is the circumference of the circle. Remember, to find circumference, you can do it in two different ways. I like to stick with 2 times pi times the radius. Some people like to say simply diameter times pi. That's up to you. Either one works. So how do I find the lateral area? Well, all I'm going to do to find the lateral area is take 2 pi r, because that gives me the circumference of the bottom, and then I'm going to multiply it by the height. 2 pi r gives me circumference of the bottom, and multiply it by the height. So that's how we get the formula for lateral area. The formula for surface area is similar. Obviously, we need to add a few pieces in because for surface area, we also include the top and the bottom. So for surface area, I know that I need the area of this right here, which is that rectangle, which we already found, 2 pi r h. It's the same as lateral area. The only difference with surface area is that I need to add on the other two surfaces. And in that case, it's going to be this circle on top and that circle on the bottom. To find the area of a circle is pi r squared. I don't know what that is. Pi r squared. But notice I have two circles. I have the one on the bottom and also the one on the top. So instead of writing this twice, I'm just going to take pi r squared and I'm going to multiply it by 2. Some people like to put a parenthesis around this to separate the fact that they're taking 2 times the area of a circle. It's not necessary, but you can if you want to. Last but not least is we have the volume. And the volume of a cylinder is simply found by asking yourself, well, if I was going to pour something in here, I'm going to pour it in and it's going to start by filling the entire bottom first. It's not going to fill up the side first, because that's not how products work. It's going to fill up the entire bottom first, which means the entire bottom is the area of the bottom. So to find volume, volume is going to equal the area of the bottom, which we already said was pi r squared. And once it fills up the entire bottom, then it's going to start filling up this way. It's going to start filling in the height. Excuse me. I apologize. Then it's going to start to fill in the height. So I have to multiply this by the height. There are our 3 separate formulas. Our 3 separate formulas. All right, let's see if I can just change the color of this one. Just so we have something different. Okay, now let's actually put it into practice. Let's actually find the lateral area, the surface area, and the volume for each one of these. So first, the lateral area. The lateral area is going to be 2 times pi, which is a number I can't change, and usually it's used 3.14, times the radius. Remember, the radius of the circle is what goes halfway across, so we have the radius right here, so it's 25, then times the height, which is 40. This is a pretty straightforward, simple problem. I'm just going to type it all right into my calculator. We're going to take the 2 times 3.14 times 25 times 40 and get 6,280. 6,280. Because I was finding area, it's going to be inches squared. Okay. Surface area, if I did not find lateral area first, for some reason, if I did not find that first and I didn't have this information, then for surface area, excuse me again, I have to go through this whole process. 2 times 3.14 times the radius, which is squared in this example, because I had to find the area of that circle, plus 2 pi, radius, which is 25, the height, which is 40. Okay, so I'm going to take, again, in this example, I'm going to take 2 times 25 times 40. That's going to give me 2,000 pi. Notice I didn't calculate the pi in. I just took the 2, the 25, and the 40, and I got 2,000. Over here, I have to do exponents first. If I did my exponents first, that leaves me with 2 times the pi, I know I changed back here, times 625. If I take 2 times 625, I get 1,250 pi plus 2,000 pi. Some examples may ask you to write it in terms of pi, so all they want you to do is add these together. If I have 1,250 pi plus 2,000 pi, altogether I have 3,250 pi. That is an acceptable answer if it asks you to solve in terms of pi. A lot of people do that just to keep their life a little easier as well, since they don't have to worry about rounding it at the end. If you use the pi key, you're going to get an answer bigger than what I'm about to give you. I'm only using 3.14. And when I use 3.14, I get 10,205. Now, my calculator is not giving me the decimal, it appears. But it would be higher if you use the actual pi key. And if I use the actual pi key, I'm just going to show you the difference here. I'm going to take pi times 3,250. And in that case, I get 10,210.17. So just know that in class, if your teacher's going over an answer and yours happens to be off by a little, it's okay, depending on if you use the pi key or you typed in 3.14. Last but not least, we want to throw our dimensions on here so we know that it is inches squared. Either one of these three would be an acceptable answer depending on the directions given to you. If you were asked to use the pi key, you'd want the answer on the bottom. If you were asked to use 3.14, you'd want an answer like this. And if you were asked to solve it in terms of pi, you'd want an answer like this. Same thing can be true up here, but we don't often see that solve in terms of pi up here. All right, last but not least, let's move on to our volume. Our volume problem says pi r squared times h. Pi r squared times h. So I'm going to take the pi. I'm going to take my r, which was 25, because that's my radius, and I'm going to square it, times the height. When I square that, I get 625 times 40, and then the pi is still out here. And when I take 625 times times 40, I get 25,000. And then times pi, again, I'm just going to do 3.14. because that's most common what we see. And I get 78,500 on my calculator. I just want to verify. For some reason, I just feel like I should have more decimals than I do. 3.14 times 25, 1, 2, 3. All right. And then I'm going to throw my label on here. Now this label is a little bit different because I included the volume, and the volume is how much it holds. Why is it to the third? Remember that here at this first problem, I took the radius, which was 25 inches, and I multiplied that by 25 inches. The height was 40 inches. Well, look, I have inches 1 time, 2 times, 3 times. So I have inches squared because they were all multiplying. Inches times inches times inches, and that's where we get the inches cubed from. So the remainder of these slides all have example after example after example on how to find lateral area, surface area, and volume. This would be a very long video if I walked you through every single problem exactly like that. So what our goal is here is I want you to pause the video, solve it, and then come back. I will work through them, but I'll work through them at a much quicker pace. Okay? All right. So hopefully you took time to solve this right now. The very first mistake that kids make in a problem like this is that they use the number 13 to solve the problem. Notice that 13 goes all the way across. If 13 goes all the way across, that is the diameter. If the diameter equals 13, that means the radius is only half of that, which is 6.5. So if you missed that, go back and change that. One other piece about this is that this can is laying on its side. It tipped over. It fell. This isn't its normal way. So note that this is still the lateral surface area where this can part is going to go. I remember that my lateral area is the perimeter of the base times the height. So then I'm just going to type all these in my calculator. 13 times 21 times, oh no, pi. That shouldn't say 6.5, that should say pi. Times 3.14 is 857.22 centimeters squared. That's my lateral area. My surface area, remember that formula is 2 pi r squared plus 2 pi RH. 2 times pi times the radius of 6.5 squared plus the answer that I got over here. So I'm just going to steal that answer rather than doing it twice. I'm going to take 857.22. Then I'm going to come back and I'm just going to solve this. 6.5 squared times pi times 2 is 265.33 plus 857.22 equals 1,122.55 centimeters squared. Now again, your answers might be a little bit higher than mine. You might have an answer slightly higher than 857 and 2200ths, or you might have an answer slightly higher than 1,122 and 5500ths, and that would be likely due to the fact that you use the pi key on your calculator and not 3.14. Again, completely acceptable. The volume. To find the volume, I take the area of the bottom, pi r squared, and multiply it by the height. I'm going to take pi times 6.5 squared times 21. I know that this is still the height because the can fell over. So remember that the can fell over. It should be 21 here. So then I'm going to, again, go back and take 6.5 times 6.5 because that is 6.5 squared. Then I'm going to take that times pi times 3.14 times 21, and I get 2,785.965 centimeters, and since it's volume, it is cubed. Volume is cubed. There are multiple different examples as we move forward. I'm just not going to go over the answers for every single one of these, but I do want to help you read through and make sure you know what it's being asked for. Here we have an example of a can. It says how much paper is needed to make a label for this can. When we're doing that, we're assuming it goes from end of lip to end of lip. Obviously, we know that it most likely would start here. Some even start down a little bit further. But we're assuming it's going to be that whole can. Remember, if I cut this and I open it up, it's just a rectangle. So the lateral area is where the can label would go. And the lateral area is the circumference, 2 pi r, times the height. Remember, don't get tricked by this one because this, again, is the diameter. So the radius would be half of that, and it's 3.5. When I look at this question, it says how much metal is needed to make the can. We have 2 points that we can look at and analyze. This specific can doesn't have a top. So if I was to make this can without the top, I would need the material for the outside of the can, which is going to be the same as that, the area of this can, which is going to be the same as that part of our surface area formula, which is going to be 2 pi r times the height, which is just like our lateral area. That's going to give me the area to this can. And then I need the area of the bottom piece. So I need to add on the area of pi r squared. If I'm asking for this can in particular, we assume there's a bottom and no top. So I only need one of those. If we're assuming that we need to include the top piece because it was there originally, then I want the 2 pi r squared, because I want the 2 circles. So make sure you read the directions and see what they're asking. Do you want the top included or not? In order to figure out volume, again, remember right here, we're getting tricked that this volume right here is giving us the diameter, and we want the radius to be 3. Then I have to find the volume of this guy. Remember, volume is the area of the base times the height. Area of the base times the height. For some of us, it's hard to visualize these. It's easier if we have those dotted lines separating it out. It really doesn't matter what you think is the base. If you think that this part here is the base because that's what it's laying on, you can do that. And that's going to be 2 times 8, because that's this. And then times the height, which is 5. Again, to find the volume, it's just area of the base times the height. If you come through and say, no, Miss Bender, this is just like one of those can problems where it fell over, and I need to say that this is actually the bottom, so it would be 5 times 2. And then this is actually the height, because this whole box fell over, times 8. Guess what? In the example of the prism, it does not matter. Because of the commutative property, it doesn't matter which way I find these. Find the volume of both and then compare. Here, a grain silo is shown below. The silo is only filled halfway full. Make sure you read all the directions. It's only filled halfway full with grain. The figure is not drawn to scale because there are a lot of people who say, wait, this whole thing is 12 and that little bitty peat is 7? That doesn't make sense. So know that it's not drawn to scale, which means it's not an exact replica. Determine the volume of grain in the silo. So, what do I know? I know that I'm being asked for it to be filled. When I'm being filled, I know that is volume. I know that volume is the area of the base, pi r squared, times the height. I can solve this just like I would anything else. Volume equals pi times 7 squared times 12. Pi times 49 times 12 is the same thing, and I have to type that in because on this morning my brain is not going to calculate that. Any morning probably. I get 1,846 and 32/100 feet cubed. I can guarantee you that this will be an option in a multiple choice because of the number of people who wouldn't have read the directions carefully. Remember that this said filled halfway. So what does that mean I need to do with my number? It means I need to divide it by 2. And when I divide it by 2, I get 923 and 16/100 feet cubed. Make sure that you read and follow the directions because this choice would be an option on your multiple choice just to see if you were paying attention. When I have to find the volume of the toilet paper roll, these are very classic questions. What I want you to remember or realize that this is the toilet paper, this part right here. Okay? And so what happened here is that I had this big volume. This whole 40 inches from the center to the end is that whole big circle here. I don't know how well I can trace it. Obviously not well at all. Oh my goodness, I really need to get better drawing circles. This right here is the circle of the outside, and I know from that it is 40 inches. So if I had to find the volume of this circle, and its height is 12, my volume would equal pi r squared times h, which is pi times 40 squared times the height, which is 12. Notice that this toilet paper is laying on its side. And that would give me the volume of that whole thing. So then I'm just going to finish calculating that for us. 40 times 40 times 12 times 3.14 is 60,288 centimeters cubed. Now, what happened in the toilet paper roll? Well, in order to put this hole in it right here, so people can supposedly hang it on the toilet paper roll, we have to cut that out. And if I cut something out, it's like subtracting. So I have this other circle here that I need to find the volume of. Again, volume is pi r squared times h. The radius is going to be 25 squared times the height is still 12 because this hole goes that whole length of 12 still. I'm going to have 25 squared, so 25 times 25 times that height, which is still 12, times pi, and I get 23,550 centimeters cubed. Now remember what I did here is I had this whole big toilet paper and I cut out the center part so I'd have a place to put it on the toilet paper roll holder. So what do I need to do with these two numbers? Simple, subtract them. 60,288 minus 23,550. 60,288. Oh my goodness, my calculator's not working. 288 minus 23,550 is 36,738. Don't forget your labels, centimeters cubed. All right, that would be the answer to the toilet paper that was left here on the roll. So, know that we will be having a quiz. On the quiz is going to be total surface area. Total surface area for a cylinder is 2 pi r squared plus 2 pi r h. Lateral surface area is going to be 2 pi r h, and volume is pi r squared times h. That is all for a cylinder. If it is a prism, which is what you learned last year, remember that it's going to be the area of the base. So usually, not the area of the base, the perimeter of the base. So it's going to be length plus width plus length plus width, depending on if it's a triangle, if it's a quadrilateral, we don't know, and then times the height. So whatever the base is, add up for that perimeter and then multiply it by the height. Total surface area is you need to find the area of every shape and add it together. That makes that up. And volume, again, is different, but it's always the area of the base times the height. Area of the base times the height. The part down here just says your